Okay, test. That should be live. Twitch seems happy. Hello, everyone. Welcome back to the compiler project. So, last week we made a lot of progress on Thursday. We rewrote the entire. Hello, how are you? We rewrote on Thursday most of the AST logic. We got rid of the old associated type families that were like clogging the whole thing in favor of something a lot simpler. We fixed a lot of issues. Doing well, thank you. Yeah, we made a lot of progress last week, and I'm excited to actually get started on the next phase of the compiler today. Because mostly last week has been cleaning up some old stuff, cleaning up some of the AST, cleaning up some of the parsing, fixing one last ambiguous thing in the parsing and in the grammar in a way I don't really like, and I really think at some point I will just have to switch to megaparsec. But at this point, everything, including like all the way to the AST, done. And everything from bytecode onwards, done. We can generate images. So tonight, we start again with going back to the analysis, as in, okay, we are gonna go through the entire parsed AST and resolve every name, check every type, and output something that then can then be used to do the lowering into IR. So yeah, let's get started. Here. So we had started with some extremely basic like skeleton stuff last time, which means we have basically a bunch of undefined everywhere. And our name for now is not extremely well defined. We're going to have to go over this again. Basically, name is going to be wherever we see a type or a variable or anything that is being referenced, we are going to replace that by a properly resolved name, whatever that ends up being. And module name, likewise, for now is just a string because I wanted to have a type that compiles, but this is probably going to be something different. It needs to uniquely identify each module within the compilation. Like it uniquely represents a compilation unit. And it's going to depend on how we want to structure the compiler, how we want to like have dependencies. If we want to support incremental compilation, there's going to be some choices to be made there. For now, string good enough for the purpose of what we're doing today. So yeah, let's get started, I suppose. We had done the very top high-level function of we initiate the scope, then we do the analysis of each top-level declaration, not in parallel, but we could. Random access lists in Haskell, you mean? Because if you mean in Haskell, I'm aware of like, what are they called? There's like a few containers that do that kind of stuff, but list specific, your use of the word list specifically is interesting to me. But yes, this is roughly the in functional languages. Does that mean with like some kind of tree-like structure underneath, or like what do you mean? If you have like a link or a paper, I'd be happy to read about it. And I think we had also started. Yep, that sounds very interesting. Thank you. Actually, you could probably post it here in the chat. I'm sure some other people would be interested in reading it. I thought I had also created. There we go. A small file for just the monad we're going to be used to resolve things. And one such thing is going to be what goes into our scope. And for now, our scope is only given some identifier, given a name that appears within our code, where does it come from? And that's going to be a non-empty list of the corresponding name. And if relevant, a top-level declaration that goes with it. And this is probably not good enough. This is probably going to need to be more information than this, or maybe name will convey the information. We're going to refine this as we go. Why non-empty? The reason I want to do this is because I want to avoid having to do a lookup through all of the modules every time a name appears. So I'm going to cache all of the names within scope at the start of the evaluation. However, a name might appear in more than one import. For instance, like maybe here I'm importing both AST and location, and maybe both of them define something named foo or something. But that's fine as long as I never call something foo in this that is not explicitly qualified. Oh, nice. Is that kind of like finger trees or something like this? Because I think finger trees are used for like some of the Haskell types for. Oh, okay, gotcha. But yes, non-empty because the same name might appear into different imports, but that's fine. It's not an error at the time we create the scope. It's only an error if at some point we try to resolve a name and it's ambiguous and therefore there is more than one match. Hence this choice of a data structure. And a name can never be removed from the scope, it can only be hidden, which is why having a hash map to non-empty is, I think, the right choice in terms of representation here. So, one of the things we could start with, which I think is going to be tricky to do, but I think is a good start, is going to be okay, we have a context, which is the modules we have already compiled. The compiler, before compiling this module, will have extracted the dependencies and compiled those other modules. So, we have, for each other module, we have a list of symbols, which is a hash map to identifier to, for now, a declaration. Probably, again, something we're going to want to change at some point, but that's what we have at the moment. And we have the list of imports as they appear within this module. From this, we can start populating the scope, as in what are the things what are the names we have in the scope at the moment. And that's something that I think we could start with. And also, we're probably going to want to think about what it would look like to have built-ins, as in names that are always already in scope, regardless of imports. So I think this is where we're starting today. Hello, how are you? I've just started. You haven't missed anything. We're starting today with like actually the analysis proper, and therefore starting making the scope of names that are available within the file we're compiling, which is basically going to be going through all of the imports to like see what is available within that scope. Which is, I suppose, just going to be traversing this is going to give me a list within the monad, and I guess this is going to be transforming that list into some kind of scope or something like this. So it's going to be a list of hash maps of things that I can just then link, yeah, that I can just do a union with, I suppose. So here I'm gonna treat each import kind of in parallel, kinda. Then here I have this list of known symbols, which is my list for each of the imports of everything that's in scope. And I create my final scope by combining all of those hash maps together. And is there a unions with? There is a union with. Is there a unions with? There is unions like this, but that's not what I want. And there is union with singular. So I think it's just going to be a fold of like, yeah. So this, the resulting map of symbols, so my scope is going to be, actually this is not in the monad. It's just going to be a fold L prime of a union with, and the with has yet to be determined, which is it's probably just going to be simple concatenation. The start is going to be the empty hash map. And the list on which I'm iterating is this known symbols. And that gives me the scope. Yep, that is correct. The fold L prime, the prime, usually for prelude functions like this, the prime indicates that the accumulator will be strict. And here I have no need for the intermediary values, so I'm just gonna use a strict accumulator. However, still constant factors lower than linked list if you're going. Nice. Yeah, I'll definitely have a look at the paper. That sounds interesting. Do you know if there's a library that does that in Haskell already, or is that like a brand new paper released like last week or something? I guess for now I can just return a scope, which is just a record that contains. Okay, it's old. Yeah, I had never heard of it. I'll have a look. Okay, I guess there's something I haven't thought of here. I think this is gonna require in the list to have. I am not extremely like knowledgeable about like implementation of containers in purely functional languages. I know which ones to use for my use cases with the libraries that are available to me, but like actual implementation of containers, something I'm not super familiar with. So that sounds very interesting to me. I will definitely read this. I think the name here will have to contain like the module of origin, because I want to be able here, if I have more than one source for a given name and the name is referenced, and I want to be able in the area to say, well, it could be either symbol foo in this file or symbol foo in this file. Okay, so it's going to be something along those lines. We look at each import, and then when we have created the hash map of symbols for each of them, we combine them like this. Now, what do we do for each import? I guess one of the things we're going to need to do is we're going to need a way to resolve a name, but not of a given like symbol within the file, but of a import. And that's something that I have not, like, again, it's going to depend on how we want to do this, so that I can look for that import at the corresponding module name within the context I have. So, what is an import? An import is I guess this doesn't belong here. And I'm gonna move this here. An import is the non-empty identifier that matches to a file, and the import type, which is the qualified, specific, or exhaustive. And exhaustive is going to be the easier case, but I guess we are able to. Yeah, okay. I guess I could make that for now the module name to be just the non-empty identifier list of the path, which means we can only reference module by the same name. All paths are absolute compared to the root, and we can refine that later. So for now, I think module name being a non-empty list of identifier. This is going to require a few imports. I think identifier is defined in tokens, which is not great, something we can clean up at some point later. Okay. So that means if we go back to the AST, each import is the path and the type. So we can do, so all symbols from that import are going to be a lookup of that import path. How is it called? AST, it's called import path, yeah. into the context that was given to us by the caller. And here on nothing, which is a small function I have in my prelude here, which is basically like put that in the monadic context and do something else otherwise if there was nothing. On nothing, I can simply report. How do I want to do this? Because I am in a context in which I am in a maybe t, which means I can short circuit by just returning a nothing at any point, and I am in a context where I have a writer for diagnostic, so I can just like print a bunch of like add a bunch of warnings or errors, and whenever I want to short circuit, just return a nothing. So I guess I could do, instead of doing an on nothing, let's get all symbols from this import. It shows result with the headline. Interesting. I'm not sure I want to try what you just said on stream. Actually, let me try on another device that is not streamed to Twitch, just in case. Now, for me, the result goes to GitHub. I had tried to book a domain name for it, and I just didn't end up doing anything. I wonder if you have like, yeah, on my phone, it seems to be working. But I'm not gonna try on my laptop just in case, because you know, if it goes to some random thing, maybe let's not do that on stream. But so here I have all of the symbols that are within this context. When that hash map is nothing, I'm gonna report some errors, and I guess it's gonna be just like a tell of something. I don't have errors for this yet. Diagnostic, there we go. But we can start with, so that's gonna be an error. Unknown import, I guess. Or import path with a module name here. Something like this. So we are going to report an error module path with this path. I call it error import path. So when we didn't find the import, we report the error, and then we hoist maybe that, I'm going to rename it maybe symbols. And now we have all symbols. So we continue in the case. Hello, how are you? Starting with the actual analysis. We're done with the AST shenanigans for now. So yeah, here we are in the case where like we had maybe a map of symbol. If it's nothing, we report an error and we short circuit. The reason why I'm using a mechanism that separates the reporting an error and short circuiting is that I want to handle warnings. A warning would be something like we add something into the writer, but we don't short circuit. So here, if we didn't find a thing, we report the error and then we short circuit. I guess I could make a function that just actually does both, given an error, like signals it and short circuits. But we'll do that if it ends up being required. So now at this point, I hoist the maybe, and I have this symbols only if we didn't short circuit. So now I can look at what kind of import that was and decide how the symbols should be put in scope. So that's going to be a case on the import type, I think it's called. Yep. The easiest is going to be, or do I want to go for the symbols and do the check afterwards? No, I think I want to do it that way. Okay. So if I look at our IST again, the import type is going to be exhaustive, qualified, or specific. Specific is just we are putting some of those names into the current scope. Exhaustive is bring all of them, and qualified is uh, the thing has to be usefully qualified and maybe with a name. And actually, how am I going to handle? I think I know. Okay. I don't think I have. What I have changed is I've changed the layout, and as a result, maybe the zoom level has changed a tiny bit, because I used to have a layout that looked like this, with the compilation on the side here, and now I've put this to a second workspace, so I can just have like a window mostly full screen, and I have a third window for Git stuff. But I haven't touched my Emacs config. So maybe some system update has messed things up, but the font hasn't changed to my knowledge, which is not saying that it hasn't. Just to my knowledge, it hasn't. And I don't know if I want to handle. Yeah, I think I'd want. It's gonna be a lot of repetition, but I think it's better to handle each of those in its own case. So let's do that. Because I think it would be correct, even if a module is not imported to qualify, to do the same thing that Haskell does, where like I have imported something from control.lens. This is a full import that imports every symbol in scope. But if I use, let's say, if it's more readable, that's great. No, this is Linux. This is Manjaro, which is a thing on top of Arch, I think. That I switched to. I used to every time I would reinstall a new computer, I would switch to a new Linux distro to be always learning a new one. And at some point, I think 4 or 5 years ago, I just installed Manjaro because it was the one I wanted to try. And since then, I've just kept reinstalling it because it has worked pretty well so far for me. It is just a full screen Emacs on Linux with again an old Emacs config that I have been. I think the last time I redid my Emacs config from scratch was 6, 7 years ago. It works. And yeah, the point I was making is like I think like here this is an unqualified import, so everything that's in control.lens is accessible to me. So if I want to access _1, which is from control.lens, I can do that. But it's also perfectly correct to do a control.lens._1 to be explicit about which module it's coming from. And I think I want to handle this the exact same way here for our own language. So I think what I want to do is for every symbol, I want to add it to the list of the scope of like names that are valid in the path, both as the qualified version and as the unqualified version, if applicable, or the differently qualified version. That way, it I don't have to do path lookups of the modules every time I encounter a variable. I just do a lookup in the hash map. I have never tried Nix. It is on my list of things to try, but a lot of my time at the moment is like I don't want to spend more time on system administration than I already do, and as a result, getting a new computer and trying Nix is something I have not allocated time for. But it is absolutely something I want to do at some point. So here, I think I'm just gonna do the loop separately for all three, just because it's gonna be different in very subtle ways, and I guess we can always like refactor afterwards if there is a so I'm not creating a functional language at all. So I'm not sure what GUIX GIX. I'm not sure what that is. Is that a UI thing? And no, the language I'm writing a compiler for is a made-up language, which is based on Rust. It is mostly a subset of Rust, a lot simpler, a lot simpler. No dynamic memory allocation, no heap, no nothing. Uh, but however, the reason why it's such a much simpler thing is because what we're targeting is not an actual compiled binary. We're targeting the Piètre esoteric programming language, in which the source code is an image. We're going to make images out of Rust-like code. To give you an idea, this small example here is the first generated image by our project from bytecode, not from Rust-like code yet. That is a simple program that prints one character and exits. But that is a valid source code in Piètre, and that's our goal. Another distro. I need okay. I need to have Oak. Again, I haven't looked much at distro stuff. System administration is not something I enjoy doing a lot, and I have not allocated time to it in a while. But next computer I get, I guess I could try. Specific would be the qualifier, I guess. So what do we do in each case? Because I think in all cases what we do is we return a list. No, we return a hash map in all cases. Oh, I guess I could, instead of returning a hash map at this point, I could return just at each level a simple association list, because I'll be dealing with lists anyway. Piètre is a fantastic esoteric language, and I love it. And it's the reason I'm doing this project. And I had written a very small thing that does what we do already, which is like bytecode to images 12 years ago at this point. But this is like kind of the idea of this. It's like, I like esoteric languages. I like using them to solve like advent of code problems and stuff. But this is a good exercise of like doing an extremely serious compiler project, taking it extremely seriously, but at the same time, in the service of a fun esoteric programming language. And no, I am not doing a code formatter, but that's part of the reason why I based this made-up language on Rust. Is because that way I gain code formatters out of the blue. I don't have to write my own. I can just use a Rust one. I can just use Rust mode when editing, unless you meant code formatter for Piètre. And I guess technically, since I'm generating the images, they are formatted. So I guess that is a code formatter in a sense. But yeah, so here I think I'm gonna change, since I don't for Haskell I haven't written my own, and there are a lot of debates on formatting. I've mentioned that in previous streams. For instance, like vertical aligning of things, I really like it, but I would not do it on a project in which like several people work, because that messes up with Git diff. But being the only person on this project, I can align everything the way I want, and I use a extremely small formatter that does the bare minimum and doesn't mess up my stuff too much. On any project with like 3-4 devs at the very least, I would just like use a much more opinionated formatter and not worry about the actual alignment of things. Because yeah, consistency and minimizing diff is the most important part. So yeah, I think I'm gonna change to actually have a bunch of lists, association lists for each import, which means here, rather than doing a union of hash maps, I can instead do a from list with the concatenation. I mean, I have strong opinions on code styles, and one of them is the second you have more than like 3 people working on a code base, you should not debate code styles and decide on one formatter and always stick to it, which is, I guess, an opinion on code style. I mean, if I encourage people to pick up esoteric programming languages, it's not the goal of this project, but I'll consider it a win for this project, because esoteric languages are fun. I think, yeah, we can reduce this if I... basically, what I'm saying here is And this is something I might change. I'm only doing it to save like save three functions. So maybe that is something that I should reconsider. But yeah, this is basically a yeah, that would have been a good name. So this is a type class that basically says a type T is analyzable if it has an associated type analyze, which is the result of the computation, and it provides the analyze function that to this to what is it? Yeah, to this type T associates a value in the analyze monad, which is this transform analyzed thing. And that way I can use analyze for everything, and each type will tell me, for instance, the analyzed version of a past declaration is a tuple of identifier and a resolve declaration. I could not do this and just use a function per type, and each function just like has its own return type. But the upside of doing this is, first, I can use analyze throughout my code. I don't have to like always say analyze type declaration, analyze struct declaration, whatever. And the second thing is I can write some generic cases. For instance, here the with location type, I'm saying that it's the way I analyze this is modify the current context to change where we are in the location of the file, and just call analyze on the like inner thing. So that's why I've used this thing, but this is not a very elegant use of type classes, and I might want to revisit this at some point. So here I'm going to output a list of the symbols that are accessible through this. Now, of course, again, please do ask questions. I'm always happy to take the time. I have no deadline with this project, which is a luxury that most projects don't have. So if it takes 2 years to finish it because I keep answering questions, that's fine with me. That's good. That's the whole reason of doing a stream. So please do ask questions about the things I'm doing. And also, please do feel free to criticize them, because I will make mistakes. So here, I think we just want to return a list per case of the list, the associative list of like pairs of name of the symbol and the thing it corresponds to. So this is going to be, I guess it's simply going to be, I'm going to make, this is going to be a do block in a list, I think. So for each, it's going to be name symbol in, or I could do a filter. No, because I'm introducing new names, so I can't do that. In the symbols of, I'm just going to name this symbols. In the hash map of symbols for this particular import that we have resolved, in the case where we have maybe a qualified name, what do we output? And I guess our result is a list that for that name will contain two things. It depends on whether this is qualified or not, I guess. Let me think. Because one of those two things is going to be the fully qualified name. I need to have a quick look at data list non-empty. I probably want, yeah, the problem is non-empty doesn't have, yeah, if I want to add something at the end, it's a costly operation. I could perhaps replace non-empty list by non-empty sequences for better insertion times, like complexity at the end. For now, that's a non-empty list, that's fine. Performance is not our first concern right now. Yeah, this little maneuver is going to cost us 40 years. Again, this project has no deadline. Yeah, I think for now, this is just going to be import path plus pure, actually, is it? It is applicative, okay, so I can just do pure like this. Import path plus the name, so that's the fully qualified version. And that resolves to this symbol. And I guess the resulting list is going to be this at the beginning of a list, which is how do I do this? Basically, if this is not nothing, I want to recreate the same thing of a import path plus the thing. And I guess I can do this with so that would be the qualifier, and that's a if I do a maybe to list of the qualified name, and then here I can return likewise a tuple of qualifier and name and the symbol. So here we're saying there's two different ways to access, two different names to access that symbol. The fully qualified one with the full import path. And if that thing is not nothing, then this new qualifier one, which if I remember correctly, AST. Oh, it is just an identifier. Okay. So that would be here. This is not correct. This would be qualifier this to create a non-empty list. Okay. I used to from 2020 to 2023. I used Haskell for my day job. That's the only Haskell job I've ever had, and I'm currently looking for a new job. So if you have Haskell job recommendations, I'm taking them. But yeah, I was extremely lucky and privileged to be able to use Haskell for 3 years professionally, and that was lovely. Before that, I have not. I have been using Haskell in my personal time for like a decade at this point, and I did have Haskell as like my not main language in the previous job. I had a job in which I managed to justify as a like secondary job concern teaching Haskell at work, which was extremely fun. Hello, how are you? I managed to like justify teaching Haskell as like my 20% project. So I would go from office to office to teach Haskell as like absolutely not my main job, but still, it was kind of fun. There's a lot of things I would do differently if I were to redo like Haskell classes nowadays, but I still stand by a lot of what was in them, and it was like absolutely a fantastic experience. And I really did enjoy this like process of creating a class and teaching them something. And I like mentioned I'm kind of looking for a new job. I'm kind of thinking of like maybe I should try looking into finding some like more mentoring stuff because like this is extremely fun to do for me at least. So here, let's do the other version, which is the one with a specific list. And I think here I want to not iterate on the symbols in the imported module. I want to iterate on. This is not a qualifier. This is the wrong name for this because specific is a list of identifiers we're importing. So that's for each name in a list of identifiers. We are going to want to do the exact same thing. Oh, in this case, actually, we are going to want. Yes, this is purely an expression in the list monad because there is no way this can fail. So this needs to be written in the actual surrounding monad. So this is the pure here. This, however, can fail. Therefore, it needs to be in our surrounding monad that is able to handle short circuiting and error reporting. Yeah, there isn't a lot of Haskell jobs, and sadly, a few years ago, the monkey paw curled of like, oh, we need more Haskell jobs, and a bunch of crypto jobs in Haskell opened, and it's like, yeah, sure, there are more Haskell jobs now. I don't want them either, but you know, there's more and more Rust jobs, however, so it's not the same, but it's still pretty nice. But yeah, here we need to be in the surrounding monad that has both the short circuiting and the error handling capacity, because here the lookups might fail. So I think what we want to do is we want to return a list in that monad, and I mean, if you manage, and it's a remote job, please, please, please reach out. Yeah, I think here I'm gonna do a sequence, which is basically we take a list of monadic actions and we execute them to get a monadic list as a result. So here, for each name in the list of identifiers, we're gonna perform an action in the surrounding monad. Yeah, I am in the EU, so remote EU would be perfect. If you manage to convince your company, I'd be very happy to hear about it. And what action are we gonna do in this monad? We're gonna be returning, or we're gonna need to concatenate this, because here, yeah. So here sequence is gonna transform a list of monadic action into a in the surrounding monad list of the values. But if each value is itself a list, that means here within the resulting monad we have a list of lists. So we are gonna need to concatenate this. And here, what do we do? What do we do in the monadic action within the list? I guess I could rewrite this as a map because this is purely a mapping something. That's a traverse. This is a traverse. I can rewrite this thing as a traverse because that's going to be for the list of identifiers, I get one identifier, and for each of them, I perform a monadic action that returns a list. And that monadic action is going to be that monadic action is going to be we do a lookup of that name in the symbols, and if it's not there, we short circuit. I mean, the tech job market at the moment is kind of weird. So I think I might do a helper function for this specific pattern, because it's already happening a second time. So let's do that. What do I want to do? Let's give it a type before I think of the name. So we have some kind of maybe a value. We have some kind of diagnostic. And, or maybe the other way around. And we want to return something that is in a maybe T of, I can't really express this as a monad, as like a generic monad, but I guess I could say on like, this is a monad writer W diagnostic M, and this has to be in some M, maybe TM of A. Yeah, I think this is okay. So that's hoisting a maybe handle, maybe? It's not a great name. We'll have to think about it. But this is gonna be basically the thing we already do, which is we have our diagnostic, we have our maybe value, and I guess here I can just do a case. Or do I do it with the is nothing? Let me have a quick look at maybe T, actually. It is a monad fail, and I think the implementation of fail is just returning. Yeah, it just maybe T return nothing. So I could just use fail there. Or I guess I could even use M0. Because it is a monad plus. Yeah, let's actually write this as a case. So in the case of nothing, I tell the diagnostic, and I return M0 short circuiting. And in the case of a value X, pure X. Which means here, this becomes a handle maybe. The diagnostic is this thing. And the maybe value is this lookup. It's a bit of a long line. Okay. And here I can do the exact same thing, which is that the symbol is gonna be a handle maybe with some kind of diagnostic that we have to figure out of doing a lookup of the identifier. I guess when I say names to be consistent with what I've been using so far. Lookup of the name in the symbols that we have. And if it is not found, it short circuits and returns a diagnostic. And what is our diagnostic going to be? This is going to be, so that's error for the import path, error import symbol, I guess, with module name and identifier or something. It's going to be an error import symbol with the module name being the import path and the symbol being the name. Okay, and likewise, probably just do that. So that's the symbol resolved, and we have an error, and we short circuit in case it's not found. And now, for this, we're going to be returning a list of the different names by which this symbol can be accessed. One of them is going to be just the name, because we have specifically imported that name. So if we say foo, that points to that specific foo. So that's going to be just name symbol. And that name is a list, so it needs to be in an empty list. Not a stack of diagnostic. It's just a list that we output. The writer just like allows a list, and this is just the reason I'm doing like a list which we can append is I want to handle warnings, which are things that we signal but we still continue executing. So that's the reason I'm not using something like the except t to just throw an error and short circuit with one error. Instead, I'm writing diagnostics as I find them, so that we can accumulate warnings before actually short circuiting when we encounter an error. And also that way, every top level definition is going to be handled separately, which means I'm going to collect diagnostics for each top level declaration separately. But no, I'm not planning to handle like stacks of diagnostic. Just like, here's a list of all the warnings and errors we found before we decided we could no longer return. Oh, actually, no, that's fine. Here I do the tail of a list. Yeah, diagnostic is just a big enum of like the different kind of errors we encounter. And here my writer will just like have a list of diagnostics, as in the list of things we have found. And I'm using list for now. It would probably be better to use something like sequence that supports like a better concatenation time. For now, again, since this would just be a change in the data structure, I'm not gonna bother too much. But this is a very easy like performance win when we start looking at performance. And here, so we've imported a specific name from a thing. So that name we've checked that it exists. Therefore, that name is now available directly into the code. And the fully qualified version is also available. So this thing here is also in the list of the association list of name to symbol that we want to have. Except symbol is not correct now that I think of it, because This is supposed to be a non-empty name and maybe declaration. And this is not what we have here. So this is wrong. And this is wrong, and this is wrong, and this is wrong. So we're gonna have to fix this. But I'm gonna still continue the top level structure, and then continue fixing the actual details. So if we have imported a specific name in an import, that name tend to be hierarchical so that it can be turned into handy code actions. I guess that's a good point. Yeah, I could. It would not be monstrously complicated to do that. Since I'm gonna be keeping a scope of like where am I in the thing, I could keep of like a stack of those errors are associated with the top level module structure. These are associated with like this declaration within the thing. This is this block within the function. I could absolutely do that. Although I'm realizing the diagnostic should probably also include like some line information, some location information. That would probably be useful as well. That being said, maybe I don't need the stack. The location information would be enough. Like maybe within the error structure, I need to also include a stack of where to find that thing so that it can simulate that basically. That's a good point. I haven't given a lot of thought yet about how to handle errors. For now, the pass errors are just absolutely terrible. That's something that at some point I think when we get closer to things actually being like actually working, because I kind of want to like make progress on all of the systems so that we can have a full pipeline of this takes Rust-like code and that generates an image. Because when we are able to iterate on something that has the full pipeline, even an extremely basic and incomplete version, then testing a lot of things becomes easier. But having better error reporting is definitely something we're gonna want to work on. And like, yeah, this one, the diagnostic not having a location is already pretty terrible because now we would just have an error that is not associated with a given line. So we're gonna want to improve on this. This is probably gonna be another data structure than the list, and diagnostic is probably gonna be something a bit smarter than just an enum. But yes, I think I want to keep working on this, even with the bad error reporting, and then come back and fix it. Just because I think having a full pipeline that works will be, as a first goal before we start improving things, will make testing a lot of things a lot easier. Here. Why did I copy that? I think that's incorrect. Yeah, exactly. 40 more years of this. My goal with this was like to try to finish before December of this year, or at least have something that works before December, with the goal of being able to do some of the advent of code in Pete, basically, by cheating with this project. We'll see where we are at the end of the year, and we'll see what the project is. And again, if it's next year, that's fine with me. So yeah, symbol is incorrect. The error handling is not great, but I think good enough for now. What are we missing here? We are missing the exhaustive case, which is the easiest, because the exhaustive case is just this, basically. And except the list is always the same. So I can even rewrite this as a very simple concat map, basically. I was gonna say a flip concat map, that's just a bind. So that's given a to list symbols, given the name and the symbol. We just written a new list, which is Basically this one. Okay, and then, so based on how the module is imported, we create a full map of all the different ways to access a given symbol. And then that's not enough. I can already see an issue here. I can already see an issue here, which is I'm creating a hash map saying like, oh, for a given name, associate some kind of symbol with it. The problem here is if someone types two imports of the same file, like import foo, which is fine, then for each symbol in foo, we would have two entries in the list, which means we would be saying like, oh, you have access like bar. Do you mean the one in foo or the one in foo? Which would be the same thing. So we need to deduplicate here. And to deduplicate this, I think we are gonna need to deduplicate based on the name. Although I guess the way to do this would be, instead of deduplicating afterwards, like I have created this hash map of like symbol name to non-empty list, let's deduplicate based on the name. I could instead deduplicate as I go by keeping here, rather than just outputting a list, I output a hash map from module name to hash map of name to information, and then I deduplicate there using the hash map stuff. Or do I decide? What do you mean? So, oh, in terms of like path, no. I mean, probably in a sense of like, I think what the module name will be is probably gonna be the actual file name on. That's a good point actually. If there is a soft link from foo to bar and there's an import foo and import bar, do I consider them the same or not? I don't know actually. I don't know actually. I'm not sure what other languages do on that note. Like, what does Haskell do here? Yeah, I think it depends on the language. Oh yes, that's just. What if I have a file which is it's way too small. That's fine. It just contains some foo, which is an int, and that is 42. And I write that as another file name bar. GHCI, and I import foo. I import. Okay, so apparently Haskell does deduplicate based on the file path. I can try. What if I... Wait, no, because I copied the file. Wait, no, so I did copy the file. I didn't do a symlink. So we need to try. What's the smallest possible cabal file I can create? New library. Test. Main is main. I'm gonna create a main. Other module. Foo bar base. That should be good enough. And import foo. Import base. Print. Okay. What happens here? Is defined. Oh, yes, because I this is I think Haskell will handle the soft linking that way, since each module needs to fully declare a module name. Here, like the base file will have a name that doesn't correspond. So I think that's the way Haskell handles it. The module name is explicitly defined. Huh, no, interesting. In place test. Yeah, the module foo is defined into files because base also defined foo because of symlink. So yeah, okay, symlink in Haskell is not gonna work very well based because of the module name. So do I want to handle this here? I haven't yet decided what the canonical module name is, except it's probably going to be based on the path. I think it's just the full path is going to be. So I don't think I want to handle symlinks as a result. But I still want to, like, even with that symlinks, I think the thing I wanted to handle was like several imports to the same module, which is a thing that will happen because it's perfectly regular to do some that in Haskell of like import this module qualified and import some specific symbols unqualified. So the same module will appear in more than one import. That is a fairly common practice. As a result, I will want to disambiguate between different. I guess what I need to do is I just need to have a top level thing of. Yeah, I guess each import needs to return a hash map from the module name to the list of symbols. Then I can do the union of all symbols in a given name because then but there might still be some duplication there. I still need to deduplicate there. Hmm. So I guess yeah, I have to create the full hash map from the start so I can do the deduplication at the right level. So here this is returning a list and that is not going to be okay. I am going to return a hash map from this. Yeah, for now I'm gonna be using just like comparison on the module name. I know that in some places for names, in instance, GHC does a thing where like the name also contains a unique hash, like a unique identifier that is an int that is used for comparison and for unicity, which means you don't have to do string comparison for this. But here, I think what I'm going to do for now is I'm going to create a hash map that's just to the module name will associate a hash map of symbols, which is going to be and I think I think I want to do the from list with union. Because I think, I think the default union on hash maps will keep here. There's no way that the same name could refer to two different symbols because we have a hash map and as an entry, we don't have any duplicated symbols. So I think this is fine. Of a list, which is this one. So for this module name, we create a hash map from those symbols. And since I'm already starting, but yeah, there might be a better function for this. Let me have a look. I want from a hash map. I want to do map with key only returns one value per key thing. That's not what I want. Okay, so I think I have no choice but to do. I have no choice. I guess I could do a fold instead, rather than transforming into a list. That being said, there's probably gonna be some list fusion happening here, so this is probably fine. Okay. Yeah, if I'm concerned about performance, I think there are better things to worry about than this. But yeah, okay. So we create the hash map of name of like identifier to resolved symbol, and then we put that into a hash map to do the deduplication across modules, and we store that in a hash map from module name to that hash map. Okay. Here we can do something similar. And I guess actually I can do this here at the top level because that doesn't need to be. So it's going to be the same thing for all of them. Okay. And so here we only want to create the hash map, which is I could almost do a I could almost move this here actually. Wait, I don't need the from list with here because there's never going to be a name there can be a name conflict at this point if someone imports foo bar qualified as foo bar, because then I would create two entries with the same path. So no, I do need some duplication at this level. Okay. So now this remains unchanged because now we're just returning the list. We are making the hash map. We're putting that in the hash map per import path. Okay. And so as a result, this should also be fine. And after this is where we end up doing something else. So this list of known symbols is a hash map. Is a list of hash maps. So here I'm gonna want to do I want to do something else? I could do something smarter. I could create a reverse hash map, as in for each symbol that is being put into the scope, here are the names it is known by. Because that way I have, rather than having this hash map of module to hash map of thing and having this complicated deduplication, each symbol will have a unique name that uniquely identifies where it's from, that contains the module name and everything. So I could do a reverse hash map of like this symbol, where is it coming from? Like by which names is it known? And then I can reverse that to create the resulting hash map. That's probably a lot smarter than doing this complicated multiple level of deduplication. So let's do that. So let me think about this again. Although that means it's going to need to be hashable, but I think it's going to need to be anyway, so that's fine. Especially because now I'm doing every symbol in the map will be returning one list of things. So yeah, that makes a lot of things easier, I think. Okay, so let's redo this because now that doesn't solve my problem because I could still have duplication in the paths and I want to handle that. Okay, no, that doesn't fix it. So maybe let's keep this because I am a bit more confident this is working. Well, the thing is, I want to build a cache of all the symbols that are available in the scope so that I never have to do all the complicated lookup in imports logic when I'm going through the file. I just want to do lookup of the name in my big cache of symbols, basically. The question is, how do I guarantee that the deduplication is correct? Because I don't want to fully deduplicate. I want to still to be able to say the name points to two different things. But if the two different things are within the same module, I want to be able to distinguish, to like deduplicate them. And so I was thinking, do I do a hash map from like the symbol to the names that point to it and then reverse that? And then I have a list of names to symbols and it's just a matter of concatenating them. But I would still need to deduplicate the names that point to them. Or do I do this complicated thing of like, for given a module, I deduplicate not with a link to the parent scope. I will not need to maintain a stack. Just because the stack will be maintained by me, maintained by the monad I'm using, as in I'm gonna evaluate the sub-expression of evaluating like the sub-tree of a given statements by overriding the current thing by adding something. But since like I'm purely immutable, I'm gonna say your scope is this for this sub-tree, and then on the way back up, it's gonna pop the modified scope to give me the scope back. So I will not need to maintain the stack myself. It will be handled by the monad I'm actually using underneath. So it's going to be basically a hash map that gets modified within the tree as I go, which is kind of a stack underneath, basically. Okay, let me think. If I can deduplicate the names given the module, and then, yeah, I think that's the right approach. I think that's the right approach. Because within a module, all the different names would always be referring to the same symbol. So I think this thing where I create for a given module, I deduplicate by name, then I resolve for all of the modules, I think is the right approach. Yes, okay, so if I do that, then I have here, when I'm done, known symbols is a hash map of module name to a bunch of hash maps of name to non-empty list that contains only one element because I have deduplicated things properly. So now at this point, So that list of hash map, I need to do a unions on it. So that way, if I import the same module more than once, then I will merge the hash maps and I will not concatenate the different things, which means I'm going to get for each name only one thing that is being pointed to, which is the correct behavior. So now I have a new hash map, which is for each module, the one and only hash map of name to symbol. And now I can take the list of the elements from that hash map, which gives me a list of hash maps. And now I can do what I was doing earlier, a fold of this, starting with where I'm going to do a union with concatenation, because the values are going to be concatenated, and the starting element is going to be an empty hash map. Okay, this should be correct at long last. No, there's no plan at the moment to re-export symbols from other modules. And I guess if we did that, we would need to. No, I don't think I want to support that at the moment. At least there's nothing like this at the moment in the language. For now, every symbol declared at the top level is exported. If we did that, we would need to decide whether a symbol exported by a file counts. Like, we would need to duplicate based on the actual original location of the thing, not on the module in which it appeared, which would be basically changing this thing here. This would mean basically going back to the idea of using the actual location of the declaration as the deduplication key. Okay, but this should be good enough for now, especially since we don't have re-exports. I'm going to want to test this because this is a bit of a nightmare. But most importantly, the big thing that's wrong is what a symbol is. Because a symbol, for now, here this is simply a declaration of the top level thing. And that is not what we want in our scope. Our scope for now is decided as being a name, which is not something we have actually decided on, and maybe a declaration. So we are going to need to do something that given a declaration and a name makes that into a name. Is the namespace flat? Yeah, basically each module is its own namespace, but there's no namespacing within the well, I guess that's not entirely true. I guess a function defines its own namespace, and like a for loop within a function defines its own, like there is going to be like a stack of scopes, but within a module flat namespace. I'm keeping things as simple as possible. So here, what I want to do is, what name do I associate with actual name, translated name, do I associate with a symbol exported in another module? And actually, should this thing actually not just be a declaration, but a proper name? Maybe not. Maybe name is a purely... Okay, so what is going to be a name? So name is going to be the way I refer to something when I do the name resolving. What are going to be my options? I guess one of them is going to be a top level declaration. And that comes from a module name and has an identifier, something like this. As opposed to what? As opposed, I guess, to like local variable, type parameter, function argument. Like, I guess those are the different kind of names we're going to encounter. So I guess we're going to extend this type as we go for the different kind of names we find and for the amount of information that we require. So here, given a declaration and an identifier, given a module name, an identifier, and a declaration, our symbol is going to be a top level declaration, module name, identifier, and just a declaration. Which means here I need to replace this with, that's the initial name of the input path, the name and the symbol, which I guess I could translate the symbols here, actually. I could do a map with key. And then I can just use symbol everywhere. That's probably for the best. So that means that here, map with key, and given some name and symbol, yeah, we're gonna associate this thing here. Okay, which means here I can do that. I'm gonna iterate over resolved. And here then symbol is going to be this tuple of name and declaration. And as a result, all of those uses of symbol should now be fine. Okay. Okay, so at the point where I think we can try to compile this function and test it in GHCI to see if it works. I don't think it's going to work on the first try, but you know. Module name, this is going to require... Actually, I'm just going to copy it because I never remember what that path is. It's this. Identifier, that's a common typo of mine. That's because that comes from tokens. Okay. So, okay, I probably have something wrong here in my map with key. Oh, flip map with key should take the hash map first. Here symbols, yep. Okay. So let's just check that the type of this is what I expect it to be. This should be a hash map from identifier to tuple of name and maybe declaration. Okay, so that type seems to be correct. That's good. So here, this is returning a list, an association list of name. So something is wrong here. Let's see what the other errors are. Oh, to list, yes. Not from list. That explains a few things. Non-empty identifier with text, okay. Aha, so I have a level where I have a hash map of non-empty identifier and it expects a hash map of identifier. Is this because my scope is actually defined wrong? That is a possibility. Yeah, here I have an identifier. This is going to be a path, so a non-empty identifier thing. Because that way I can compare the fully qualified path of anything to get access to the thing it's pointing to. Okay, next. So the type of this expression suggests that this should be a hash map of non-empty identifier to, which is the module name, to a hash map of non-empty fire to non-empty, yep. Aha. Yes, here I have only one thing, one tuple, and I need to, and actually since this function is only used one, I'm gonna remove it and inline it. It goes here, and this become this, but it needs to be put in a non-empty list, so this becomes that. Okay. Top level declaration module name. Yes, in this case, that's the import path. Name symbol. The names are different here. What else are we missing? Resolved. Yes, this is no longer true because now this is a non-empty list. So I can remove this type of annotation, which is now wrong. Okay, so that compiles. So let's try a few things. Let's have a few declarations at the top level. Let's create some hash maps to have some context, and let's try to see if resolving the imports do what we want. So let's have a foo, which is going to be a const info. Let's go back to the AST. This is going to be a declaration, so it's going to be a const declaration of a const info, and const info is this thing. So it's going to be an identifier foo, and it's going to be the name type, which is going to be the unique name associated with the thing, which for now, can I... This is a top level declaration that happens to be in test.foo with the name foo, which means there's a bit of repetition there, that's fine. And an expression which is annotated, so it has the location. Well, at that point, it will no longer have the location, so that's just an expression And I guess an expression would be, I could just use a int literal expression. Could not is, yes, okay, this is, I will need to do something like this. Because that's a non-empty list. Okay, so that's one declaration. Now let's do bar in another module here with another value. Oops. Okay. Now let's create a context for this particular function we are trying to do, which is this one, initial scope. So we are going to want to have a very simple scope, which is a hash map of a module name to symbols. So our scope is going to be I haven't imported a thing, so it's not going to work. I'm still going to type it for now. From list, and this is going to be this module name associated with a hash map, which is going to be this one. And the second thing is going to be a non-empty list of strings for the path, which is going to be test bar. And that second module in our scope will only contain one declaration named bar. There we go. And I will need data hash map strict qualified as M. Okay, so that's our scope. Ah, interesting. Okay, so I could actually specify it as being, I guess it's just enough, I suppose. It's because foo is ambiguous, I think. Yeah. If I say here declaration resolved, oh, I have more than one resolved. Okay, so now the scope of this is, okay, so it's still a bit more generic than it needs to be, but that's fine. So now we have our not scope, actually, it's called context. I give it the wrong name, but that's fine. So given this, what happens? What's the initial scope? Given that scope, which I should have named context, but that's fine. And if my list of imports only contains a qualified import, well, it's an import contains two things. It's an import of, is there an is list instance of non-empty list? I think there is. It would be a lot easier if I could just type test foo. And this is an exhaustive import. Okay. What's the name? Overloaded list? There we go. Okay. Except scope doesn't have. And deriving show. Let's see if this works. No instance for show name. I need to do some. I'm surprised by the amount of moderation I have to do. I am not like I don't have a large audience, and yet I still need to do that kind of like moderation every single time. Oh, someone has been faster than me. The account is already gone. No instance for pretty name. First philoscope. Why would this need? Why would trying to print scope require an instance of pretty name? That feels nonsensical. That's some AST shenanigans there, and I suppose this is probably because I have pretty name type here in the constraints which are used for the show, which I don't think I want. So I think I only want it listed here, which means I'm going to replace this. Yeah, I guess it's the downside of having a big list of constraints like this that is kind of irrelevant for what I want. It's like that; those are the show constraints, basically. Yeah, okay, so I'm going to change this to B. Oops. Let's go back to this then. Let's see if this is enough. And let's say pretty constraints here, where show is probably not required. And I don't know if the annotation is required. Let's see. So this would be, I'm going to comment it out just in case. And that means here, here I can do this. AST constraints, pretty constraints. Okay, that way I don't need a dependency on pretty for show, which seems okay, and that is only within pretty, which means I have to uncomment this, I think. Let's see. Okay, that looks better. Okay, which means I can reload GHCI and go back to where I was. Okay. Oh, why is this? Why is this giving me an error here and not here? What the hell? Okay, well. So let's redo this. That's ooh, that's bar. And I can declare this slightly differently. Let's do the scope and let's rename it context this time. And I need the import. There we go. And I can redo my initial scope with the context. So given this context of those two modules, add those paths with one declaration each, if I import test foo exhaustive, what's my scope? I need to set again overloaded list. There we go. Okay, and that gives me a maybe writer identity thing. So I need to run that. And we do that with run writer of run maybe t. Okay. Import control monad writer, import control monad trans maybe. Okay. So now that we do this, we get this big thing. So our scope has only one thing, which is the scope names. And actually, I might just do f map. Oh no, actually, from maybe, maybe in, yes, maybe MMT or scope names of this. Ah, yeah, okay. That's fine. It's hard to read, but that's fine. So here we're saying that in our scope, if something is referred to as test foo, so the full qualified name, that is our top level declaration of foo. If something is referred to as just foo, that's the same. Okay, and nothing else because we have only one import, which is the exhaustive one. If I import instead this as qualified as bar for some reason, well, if I import this qualified with nothing, then the only valid way to call foo is the fully qualified version. So test foo, and there's no other way to call it. That's fine. And if I import it qualified with just bar, then now bar.foo and test yes, test foo and bar foo would both import the same thing. Okay, perfect. That seems to be working. Now, if I try to import something that doesn't exist, I get nothing and I get an error. Perfect. If I try to import something and I am doing a specific with a list of identifiers, but that doesn't exist, I should get an error. Perfect. And now for the test, what if I have let's say I import this foo thing qualified as just bar or just f, let's say. And I also import it again with a specific list of imports to mimic this thing of like we import the full module qualified and some of the things unqualified. Specific, that's going to be a list that will contain just foo for now. If I do that, I should deduplicate the thing properly because it appears in more than one import, and yet I should have only three valid ways of accessing the thing. Test foo, which is the fully qualified version, is there. F foo with the new qualified name is there. And just foo should be there as well. I don't see it. This is hard to read. Because here that's one of them. That's a top level declaration. Then here's the second one, which is accessible as F, which is the qualified version. I don't see the third one. I would expect to see it as a third one because of the specific one, and I don't see it. But maybe because this is hard to read, maybe if I do... so let's do an F map. So let's get the first, which is the maybe thing. And let's do an F map on this. And I'm going to do print the keys of the scope names. So there is only two ways to access it. There is the fully qualified, and there is the semi-qualified. So the deduplication of two of the same import did not work. Okay. I know why. Because here I do the unions with the name symbol, and that's gonna keep... Oh god, okay, I see. This is gonna be a full L of union with, and here in this case, that's just gonna be the regular union, I guess? Because here I'm doing the union on hash... Yeah, I think that's correct. So here I'm doing the union of hash map for a given module. So I want to do the union of the hash maps within, which will keep only one element. Then I take the elements. So now I have a hash map of name to a list, and there I do. Yeah, okay, I think that's correct. Let's try that. I don't know why this doesn't work in GHCI for some reason. Oh, because I have set is list. I have set an extension to the language here, which now makes something ambiguous when I load this module, because that extension is not set, however, when I compile. That's why. Let's try again. Let foo, let bar, import, let scope, or let context rather, and now let's try again. And now it has been deduplicated. There is 3 different ways to access foo: fully the name foo itself, or just as or prefixed by f, or God, this is hard to read. Just foo or f foo or test foo foo. Okay, that works. And to be convinced that this is correct, let's redo it with another version, which is going to be, let's import the same module exhaustively 3 times. And if I do that, I should still only get 1 entry at the end, because there is only 1 way, well, 2, because there's 2 ways to access that value: fully qualified or unqualified. Okay. Phew. So now I think that's correct. So now we've made the thing that, given a list of imports and a list of known symbols, initiates our scope, which means we can start going through the module of the things that we're trying to analyze. And for each of them, we have a full list of the names that are in scope. And if there is more than one module that defines them, we will have a non-empty list with more than one element. And we are able to handle errors like that. Okay. That was tricky to do. And this probably you could use a comment. But that is a good thing done. Now, let's go back here. And let's start analyzing things. So we've done the top level declaration, which goes into analyzing a declaration. What do we want to do? I guess a constant declaration might be the easiest to get started. It might be complicated because we might need to keep track in the fact that we are in a constant, and therefore some things will not be allowed there. By which I mean a constant declaration is something that we should be able to fully resolve at compilation time into a value. So the kind of expressions that are allowed in a constant is gonna be restricted. But constant will be allowed, is the thing. Oh, there's something I'm missing in the initial scope. There's something I'm missing in the initial scope. We're not done with the initial scope yet. Because this is the stuff that is coming from the imports, but that's not all the names. That's not all the names in scope. I will want to have something that points to. I will want to have something that points to a dummy version of the declarations within this module I'm compiling, because otherwise I'm not able to do things like a constant that depends on another. I will need to be able to do a lookup within the module. Therefore, things within this module need to be part of the initial scope. And as a result, this is going to take the full module. And I'm going to replace imports by mod imports. Okay. And so here to this list of scopes, I'm going to add another hash map, which is the one of the local names, which cannot be referred to fully qualified, I think. I guess they can. I guess there's no reason for this specific module name to not... Like, yeah, if I'm in a module that declares something named foo and that imports another module with something named foo, should this local name take precedence always, or should I be able to refer to the local name qualified to be able... Let's test that. If I go back to... I'll test this with Haskell, but you know. So let's take this example where I have a file foo that declares something named foo, and then I have a file main that declares foo equals 41 instead. What will the error be here? Oh yeah, I need to change this to remove baz that no longer exists. I guess. What's the syntax again? It is build depends. Okay, so yeah, it remains ambiguous. And here I could do main.foo to fully qualify the current module to make it clear what's happening. Okay. Perfect. That feels correct to me. That means that here we're going to need to do the same logic for the current module, which means we're going to need to generate a hash map for the current module of likewise all the names in it either directly or fully qualified. I guess this could be, I could cheat here by, instead of doing it within this function, I could have the top level function add a fake import for this, basically. But maybe it makes more sense to do that in this function anyway. Because what I'm basically doing is creating a fake import of an exhaustive import of this current module name within the scope, basically. Yeah, I guess I can do that. I can just create a fake import here and add it at the beginning of my list of imports. And the fake import is going to be... Oh, and I need to modify the context as well, actually. So maybe actually I do a top level function that does create the fake stuff and then calls... Yeah, something like that. So it's going to be actually incomplete context. And this is going to be in all imports. And here I'm going to define some aliases in this function. All imports is going to be fake imports added at the beginning of the module imports. And context is going to be the union of fake context and the incomplete context. There we go. And what is the fake import? The fake import is very simple. This is an import of this name exhaustive. And I'm using this to basically redo this logic here without having to duplicate it. Although I guess it's a lot of work for something that ends up being not that big. Maybe that's too much work and I don't need to do that. Maybe it's easier to just duplicate that for the current things in scope, I guess. Yeah, maybe this is the wrong approach. Okay. Also, yeah, no, I think I'm gonna change this. So that remains the same, but that's mode import. So this goes away. So local scope is gonna be a hash map, which is gonna associate to each name in from a list of concatenate something, I guess. I might not even do concatenate. That's gonna be so for I will need to get for every declaration in the declarations of the current module. So mod declarations for each of those, which is, I think it's not a hash map, it is a simple list because the order matters at this point. So for each declaration in that, I'm gonna need to get to translate it into a fake dummy one, and which gives me a name. Oh, and this is also probably where I'm going to handle. I probably want to handle the duplicated names at this stage. Hmm. This is not just making a hash map, because here I'm dealing with name conflicts that I need to resolve at this point, I think. Again, let's go back to our small example. If I go back to main, if I have two things named foo here, at what point does that get resolved? I guess I need to handle this. Does this happen before? Yes, the multiple declarations of foo are an issue before we try to resolve any of the declarations, because if I remember correctly, GHC does the same thing of doing some basic resolution of top level declarations to then being able within the analysis of each declaration to know what the other top level declarations are. So it doesn't see this error because it sees the duplication first. So we need to do a similar thing where here, when I create my local scope, I need to do, this is where I need to create a dummy resolve declaration for each thing, despite the fact that it hasn't been analyzed yet. And this is where I will have to deduplicate names. Okay. So I guess I'm gonna delegate that to another function because that's gonna be a lot of work. So this is going to be local scope, which is going to be delegated to resolve, initialize local scope, which is going to take the full module name and the declarations, which returns this in this current monad we have because we want to be able to short circuit and return errors. And at the end here, imported scope is going to be this monstrosity. Which I probably want to reorganize it any bit, even if it's just doing that. And the resulting scope is going to be the concatenation of the local scope and the imported scope. What happens? What happens if I try? Maybe there's another error case I need to handle. What happens if this foo files imports foo? How is that handled? Module imports itself, and that just fails immediately. I suspect here this would be handled when we are at this point of creating the initial scope. We have a scope in context of like, hey, those things we are importing, here are the resolved symbols. Which means if a module were to import itself, we would already have detected it, which means here we don't have to handle the case where the same file is imported again because we have a way to detect this. Okay. So I think this is now correct. We just have to create an entirely new function that initializes the local scope. What time is it? Not too late yet. Okay. Which here only takes the module name and a list of declaration passed. And that is where we're going to need to be smart, because this is where I'm basically going to want to create a resolved version of this without actually fully resolving the declaration. So it's going to be a dummy declaration because I only need this to be resolved for type checking purposes. So how do I do that? No, let's try to do it and see where we struggle. I think this time I want to not do this as like each element individually. I will want to do it as a fold or even as a state, because I need to be able to keep track of like which ones I have declared already. Yeah. What a mess. Purely because I have 10 years of using Haskell and I like it, and I've used OCaml once in my life in 2004. So, uh, yes, Haskell is the one I'm used to. My engineering school made us start as soon as we like the very first year with OCaml and Delphi at the same time, which was quite the interesting combination. And we moved on to C after like in the third year, then C++ and a bunch of other things. But as a result, I don't remember a lot of OCaml. I guess that arriving from Haskell, a lot of OCaml will feel familiar. But again, it's been 20 years. Okay, so all this is going to go away. I can just get rid of this. I don't know if I want to handle this with a state or if I just want to handle it with a fold in which the state I'm pass like I'm just it's just a manual state passing basically. I am not familiar enough with OCaml to be able to answer that question. I don't see why it couldn't from what I know of OCaml, but again, I haven't used that language in 20 years, so I would not feel comfortable answering a question about OCaml. But I would be surprised if it were not possible to make like parser combinators in OCaml. Sure thing. I do love parser combinators quite a lot. I have actually written like a few years ago a small introduction to like how to do parser combinators in Haskell. It's fun. Yeah, I think for now I'm just gonna do. Oh, Twitch, are you okay? Ah, shit, I've lost the chat history. Hmm. Welp. But apparently the stream is still running. Twitch just happened to be weird. Okay, so I think I'm not going to do this with a state, although I could, just because I think I should be able to resolve everything without looking up other things I've resolved, hopefully. Okay, perfect, thank you. Oh, actually, will I need... I will probably need to use this scope that I have made here. Yeah, probably. I should probably give a name to this pattern given the amount of time it appears. Okay. Okay, yeah, let's try this. For now, I'm not gonna keep a full state. This is gonna be imported scope. So what I'm gonna just do is a fold with an accumulator where my starting accumulator is an empty map. And I'm gonna go like go something, and I'm iterating over the list of declarations, so I don't need to name it here. And I guess I can do as a result a flip fold L prime with MMT as my original accumulator. And then every step of this is my accumulator, which is my list of things, of symbols that I'm making a local scope for, and a declaration. which I guess is this. Now, that means I have to handle the case of each type of declaration at the top level. So basically same thing as this. The question is, can I reuse? Can I instead? No, I cannot reuse the existing analyze functions, well, existing future analyze functions, because I am not in a world in which a scope is already initialized because I am currently creating it. So I am going to have to do things a bit more manually here. Because I am only partially resolving. I'm doing a partial resolving here. Only up to the point where the type is fine, basically. None of the actual. Yeah, for instance, for a constant, I don't need to resolve a constant declaration beyond just the type, because this is just to have things in scope for the purpose of type checking and for the purpose of cross-referencing future things. So let's have a look at what this would look like for the local scope for a constant declaration. So let's start with this. What is a constant declaration? Let's go back to the AST. It is an identifier, a name, and an annotated expression. And the name being the type. Oh, I am missing something already. There's something else I'm missing already. Which is that this scope here needs to also contain. It needs to contain the built-ins. Built-ins will come from something else. So I guess in the name of something, I need to also have something that is a built-in name, which won't have a module name that makes no sense, but I guess just an identifier. Okay. And here I can start making in the batteries built-in. There we go. Do I want to do that here? That kind of makes sense. What I'm thinking about is the reason why in my scope here I have here the name that maps to whatever this identifier is and maybe a declaration. The maybe declaration is for type checking purposes, as in I'm claiming that this name is a, I guess, like I'm claiming I'm accessing like field foo of that thing. Is this a struct that contains the name foo? But not all things will have a declaration. I guess for built-ins, I can do the resolving purely on name and on trust, and there won't be actually a mapping declaration. That's fine. So I guess the list of built-ins is just gonna be a list of identifiers. But would some of them have a declaration? Some of them would need to have a declaration for type checking purposes beyond the name. Like, for instance, functions would need to check arguments and stuff. So I guess for now, I'm just going to do this. That's just going to be a list of identifier to maybe declaration resolved, which is going to require a ton of imports. And for now, my built-ins are going to be a non-exhaustive list because I'm not going to put any of the functions yet. For now, we're going to have int nothing, and that's going to be good enough for this evening. Which means here, when we are doing analysis of the local scope, we need to have built-ins as well. Which is simply going to be a from list to create a hash map of a transformation of the built-ins where to name and declaration I am doing I guess I could already do that in the built-ins. There's no point in doing this here. So those are going to be let's use that type for now. Missing one parenthesis, there we go. So pure int is going to be associated with a non-empty list of pure a tuple, which is built-in int and nothing. Okay. Okay, so now we have the imported scope, we have the built-ins. We can look at the initial scope of the local scope. So I have a constant declaration here, which is a const info here. What do we do with this? We are going to want to output a resolved version of this, but we don't care about resolving the expression. It is okay for this fake resolved declaration to contain no expression, contain a dummy thing, because it's only going to be used for type checking the local module. So what do we do? I guess here we are only going to be interested in checking that the name doesn't conflict with another local name. And check, do we even check that the name is in scope? If we go back to our example here, like how much resolving do we actually do at this point? So here we're trying to like import food doesn't work. If I go back to, was it from main? But yes, I had to rethink here. Here I have two conflicting declarations, and I don't even look at the expression at all when I do this resolving. Would I even look at the type? Or would it even fail? Like, not even look at the type because it doesn't really matter. Yeah, multiple declarations, it doesn't even look at the type at this point. So I guess I don't really need to do the local like built-in check or anything. Resolving at this point means the bare minimum. So perhaps I don't even need to check to do any like checking of the built-ins or anything. Maybe at this point it's enough to just create something. So the dummy resolved info is going to make a const info as well. With the same identifier, the same const name, that hasn't changed. And here it's just the const type needs to be resolved. That is, I need to transform this, which is a non-empty list of identifiers, if I remember it correctly. This is a path info, and I need to transform that path info into a proper name. I guess I could do it at this point. There's no reason not to. And I guess there's going to be that much work done when I try to actually analyze each part of the file. So here I'm going to need to resolve the name. But what happens if it's a name that's in the current scope? Could I not resolve at this point? Would it be fine to, at this point, store the unresolved information? Would it be fine to, at this point, store the unresolved information somehow? Because if I don't do that, then I end up with having some cyclic stuff where I'm always going to have some cyclic stuff. It is possible to define a struct. I mean, our language should not allow it, but it is technically possible to define a struct A that contains a field of type B with the struct B in the same file containing, unless I give up on the idea of the order of declaration doesn't matter in a file, and I change to like, actually, no, the order of declarations matters. And that solves this entire issue. Does the order of declarations matter in Rust? I'm assuming it doesn't. Like if I have some foo here, I can absolutely do foo here. Because maybe if I give up on the order, then a lot of things become a lot easier. Curious to see if Rust allows it. Yeah, it does, of course. No surprise here. Okay. Okay, so how do I solve this problem of circular dependencies within the names of the module I'm currently compiling? Because I need to have access to the declaration of other things to be able to do type checking. But here I probably don't want to do exhaustive type checking because I am only doing the bare minimum to have a resolved declaration in the top level so that I can check that things are. I guess here, the only thing I'm trying to do for the constant, because here I don't really need. Yeah, I think the only thing I care about is finding out where the name comes from. And I don't even need to fully resolve it necessarily, because if it's local, give me a second. Give me a second to think about this. When I do the analysis of a given function, I will need the order in which I do the analysis then will depend, like I will need to do them in order. I will not be able to just iterate on all of them and decide, yeah, I can just do all of them in isolation. I think, because for instance, if a function in my file returns a value of a struct in my file, then to do the type checking, I will need to have fully analyzed the type in question. So there is an ordering to things. But what's the bare minimum I need for this resolving here? That being said, mutually recursive structures will not exist in this language because, yeah, but trying to make taking shortcuts because because the language is limited feels wrong. I think I want to handle this properly. So I need to figure out two things. Can I do the resolving of anything in isolation without having fully resolved anything else? So having just like the dummy resolved version, is that enough? Like, would the unresolved declaration of everything be fine? Or should I always resolve all the types before I resolve everything else? How do I handle mutually recursive types? And what do I need for the top level scope? Can I just say, hey, this name isn't scope and it's a local thing? Go back to the fully resolved definition when it's available. That's also a possibility. Like by which I mean, do I have a like local identifier Like, hey, that's not something that comes from another thing. That's probably the local one. Check later, basically. Or do I want to go the complicated route? And I think I probably do. In the sense of like using laziness to construct a hash map of symbol to thing, while at the same time using circular logic to be able to do lookups within that thing. Like memorization and. I think that's what I want to do. I think that's the cleaner version that avoids having to create dummy things. I think that's the proper thing. But that is horribly complicated. So I am tempted as a result to stop here for this evening and to start thinking about what that means for next time so that next time I can tackle this. So we did the resolving of the imports this evening, which is already some progress. Now, yeah, I think I want to think about what it means to resolving the top level declarations of a thing. Because I guess it's just a matter of like, this points to a local name versus this points to another name. Do I even need to do that? Do I even need to do that? Come to think of it, is it enough for me to know, oh, this name is within the scope, therefore, like for instance, what if when I resolve this top level thing, I am basically just creating a empty hash map for the top level stuff, which just serves to check for deduplication and to say whatever this thing is, it happens to be declared at the top level at the top level. And I don't associate any declaration with any of the things in that thing, which means then that when I am doing the analysis of something, then I will need to go check its full declaration. Yeah, I think that might be for the best. That doesn't fully solve my issue, however, because I will still need to be able to then do my declaration. Like I will still need to be able to create a graph of local declarations to be able to resolve them in order, basically. As in, I will need a fully resolved type to be able to do the type check of a function that uses the type. And how, in this case, do I handle? How do I handle in this case? I think it's fine because types are easy to resolve and therefore can be resolved probably without. Hmm. Okay, I think that's gonna work. So I think I can make progress with this and push the problem down the line. Okay, so local identifier. I think that's fine. which means as a result that I'm just gonna extract the identifier from every declaration and push. Yeah, problem for future me, I think. But also because I think I see how that's gonna work, and I think this is enough. Ah, yeah, I think this is enough. So I think at this point, therefore, I am creating a very basic scope that says local, and we're gonna update the scope whenever we do something to update the scope to contain resolved identifiers. And hopefully by the point we're done, there's never gonna be a local left in the thing. Yeah, I think that works. Okay. Okay, so that means here I am created indeed some dummy stuff to go in the scope that just like says unresolved. And at this point, the only thing we check is name collision, just like Haskell does. So that means what I need for a given declaration I need to return for each of those. I need to insert into the hash map and I need to handle errors. Okay, so that means I need to know what the identifier of that top level thing is, which is going to depend on the top level, the kind of top level declaration this is. Which here is just going to be the const name. I'm going to copy this. And this is going to be a type alias info or something. Yep, that's what it is. That's probably going to be an enum info. That's going to be a struct info. And it's going to be a function info. Since I am, again, the only person working on this, I can vertically align everything. There we go. So that's an alias name. That's an enum name. That's probably a struct name. And I would be surprised if this were not a fun name. Let's see. Yep, there we go. So that gives me the identifier. And now, what I want to do is I want to detect collisions at this point. So I'm not doing any resolving, I'm not doing anything else. I am just gonna check So let's do a lookup of the identifier. I guess there's going to be pure of this because it's going to be a non-empty list. And this is going to be lookup of this identifier in the map. Oh, it would be good to have the location there. But I don't have that yet, so for now my error message is going to be bad. That's fine. So I look up the name in my accumulated map. If I find something, Actually, yeah, I guess in which case I could just re-go through the list. It's fine. If I find something, here is the error case where there's more. I need to report the fact that there's more than one thing. So this is going to be a tell of some diagnosis thing followed by a M0. And that tell is going to be a duplicate diagnostic. Error multiple declaration of identifier. And otherwise, wait, that's a fold. That's a fold, but I want to be in the monad, so that doesn't work. I need to do this differently. Which is there a fold M that does what I want? Yeah, fold M seems to be doing what I want. Accumulator value, yeah. So, and in the case where there is no such name, there is no problem of multiple declarations, and I can return M insert of, or I guess I can do accumulator union M from list of identifier and a pure tuple of a name which is local. I probably don't even need the identifier, so local is probably just fine. Nothing. And I want a second element in that list. Because I want to also have the fully qualified version, which is this yoke, except with the full path at the beginning of it, which is the module name here. Okay. And now that just means that every time in the scope I encounter local, I need to make sure that the thing has been done first. And if I ever finish resolving something with some local that are not done with, that means I have some weird circular things. Yeah, I can proceed incrementally by replacing the local name in my scope as I go, I think. It's going to be a tiny bit of bookkeeping, but that also allows me to keep track of the circular nature of things without having to rely on laziness. I think this is good enough. Okay. So with this, we should have all of the local scope. And in built-ins, what do we have? Yeah. Oh yes, pure case decla of lax initialize local scope. Built-ins is from battery is built in. from list that is from this. And this is this name. Okay. An initial scope requires more things. It requires the module name. And it requires... Actually, do I still need the module name then? Probably for errors, I guess. And it requires the full module. I guess I could say this name and this. Okay. So, okay. Those are annotated parse declaration, which means they have the location information, which would probably be useful for errors. But that means for now, since for now I'm not using the location information at all, I will need to it's the located thing I'm interested in. Up. Ah, yeah, okay. Okay. I don't need the scope since I am not doing any resolving beyond just creating the base stuff. There we go. And I guess I could, because now I want to change something in this. Because I have the local scope, that's done. And now I want to analyze the module, therefore go through each top level declaration and actually type check it, resolve it. But I will need to resolve some things first. I will need to do some graph analysis of what depends on what, basically. The very basic thing is, of all my declaration types, some are trivial to do first. For instance, enums can always go first because they don't depend on anything else by definition. Type aliases and struct are at the same level. constant can then go next because they only depend on the type. And in fact, can constant be of a non-built-in type? Yeah, I don't see why they could not. I don't see why a constant could not be of like constant struct something. And then at long last functions. And I will need to be able to do this kind of like graph walk of things because I want to be able to say constant A depends on constant B, which is fine, but not if constant B depends on constant A. Constant cannot be mutually recursive, that doesn't work. So I am going to have to do this kind of like I guess that's the thing. Is basically since for most cases no, actually circular definitions are valid for something. Functions is perfectly fine. I guess that still means I'm not gonna do resolving declarations in order as they appear in the file, like I do here, of just like go through where is it? Map run analysis this name on the thing. I think that's not gonna work. I think instead I'm going to have to keep a same scope across different things and basically for each of them try to analyze them. If I need to resolve a local thing first, then recursively go to that thing and update the scope accordingly. Yeah, I think that's the proper approach. The only thing is, how do I handle mutually recursive things? I guess I don't need to do a lot of work for like I never need to fully resolve things. For instance, like just take let's just take the most basic example. If I have a recursive function that calls itself, I will only need to have the very basic stuff resolved, as in the types. So do I need to do this basic type resolving at this point then in the local scope? Or do I not need that? I think this is enough for this evening. I think we've already made some progress. I'll write something on paper for next time to have a clear understanding of like this graph notion of things and how do we avoid doing some laziness not tying things. And what's the bare minimum amount of resolving I need at every level? Okay, I'll put that on paper for next time so that next time we can actually get started with, well, continue with the analysis of things. I think that's the biggest difficulty of this phase, and when I figure out this problem of like mutually recursive things and recursion, then things become a lot easier. But I just need to figure that out. Okay, that's gonna be enough for this evening. Thank you for tuning in. I'll be back on Thursday for more of this, and by then hopefully I'll have a bit more. I'll have a better, clear understanding of how to do this. Although what I have here is like it is already a lot more clear to me than it was like a week ago, but there's a tiny bit more I need to think about ahead. Well, thank you again for tuning in, and I'll see all of you on Thursday. Oh, and I forgot to mention on stream, but the second YouTube channel with the full archive of the streams is up. There's a playlist with all the streams in order. I'm missing only 2 streams. The very first one, that's not a big deal because that had a bunch of hardware issues and we didn't make any progress. And I'm sadly missing the 1st of April stream because that's the one, and because I just didn't donate it in time, which is a bit sad. It's the one in which we got derailed by the Alex bug, but that's so be it. So yeah, thank you again for tuning in, and I'll see you all on Thursday.